In this video, we will be taking a look at the autoregressive model. The term autoregression indicates that it is a regression of the variable against itself. Autoregressive models are remarkably flexible at handling a wide range of different time series patterns. Thus, an autoregressive model of order P, also written as ARP model, can be written as yt is equal to c plus summation of I equals to 1 to p phi I yt minus I plus epsilon t. In this equation, yt is equal to the prediction at the current time step, yt minus I is the ith lagged value, phi I is the coefficient of the ith lagged value, and epsilon t is the error at the current time step. P is the number of time lags taken into consideration. Let us use the AR model in a real life example. This is your friend Raj. He just finished with his English exams. He feels he is weak in that subject. To plan his studies and to select subjects he would like to focus on, he wishes if he could predict his future marks. To do this, he asks for your help. You ask him for his English scores for the past few years. We would like to find out his marks for the 11th and 12th grade. Considering that the marks in English of a grade would only be influenced by the marks in the previous grade, we can come up with an autoregressive model. The equation is as follows. Yt is equal to 50 plus 0.3 yt minus 1. In this equation, yt is the English score in the tth year, while yt minus 1 is the English score in the previous year. To predict the English scores of Raj for the 11th grade, we need to calculate y11. Using the AR model, we can see that y11 is equal to 50 plus 0.3 y10, which is the English scores in the 10th grade. Therefore, y11 is equal to 50 plus 0.3 into 66. Hence, we can predict that y11 is equal to 69.8. To calculate the English score in the 12th grade, we need to calculate y12. Using the AR model, we can see that y12 is equal to 50 plus 0.3 y11, which was the score previously calculated in the 11th grade. Therefore, y12 is equal to 50 plus 0.3 into 69.8. Therefore, English marks in the 12th grade, that is the y12, is equal to 70.94. From the predicted values, we can conclude that Raj has room for improvement in his English scores. Raj feels that forecasting his future marks will help him in planning out his studies. So he again asks for your help, this time to predict his math marks. These are the marks scored by Raj in the past grades in math. We want to predict the marks which he'll score in the 11th and 12th grade. Mathematical theorems and formulas taught in a particular grade serve as a foundation for the mathematics that will be taught in the future. Hence, instead of just one previous time step, we consider two previous time steps to predict the math scores. Hence, the equation for the AR2 model to predict the math score looks like yt is equal to 0.6 yt minus 1 plus 0.4 yt minus 2. Here, yt are the marks scored in the tth grade, yt minus 1 are the marks scored in the t minus 1th grade, and yt minus 2 are the marks scored in the t minus 2th grade. To predict the marks for the 11th grade, we use the equation for the AR2 model. Therefore, y11, that is the marks scored in the 11th grade, is equal to 0.6 into y10 plus 0.4 into y9. y10 is the marks scored in the 10th grade and y9 are the marks scored in the 9th grade. Therefore, y11 is equal to 0.6 into 97 plus 0.4 into 90. Hence, y11 is equal to 94.2. To predict the marks that will be scored in the 12th grade, we again use the equation for the AR2 model. Therefore, y12, which is the predicted marks scored in the 12th grade, is equal to 0.6 into y11, which are the predicted marks which will be scored in the 11th grade, plus 0.4 into y10, which are the marks scored in the 10th grade. Therefore, y12 is equal to 0.6 into 94.2 plus 0.4 into 97. Therefore, y12 is equal to 95.32. From the predicted scores, we can conclude that Raj is pretty good in math. Up until now, we were choosing the value of P or the number of time lags in the ARP model without any statistical measure. This can give us a wrong model. To bypass this issue, we use the partial autocorrelation function or PACF plot. Correlation is an indicator of relationship between two variables. Autocorrelation refers to the relationship of a variable with its previous time period values, also called as lags. This is indicated by Pearson's correlation coefficient, which lies between -1 and 1. In PACF, only direct effect of values in previous time lags is considered. Using PACF, we get the value of P that tells us the number of time lags before the current one having high correlation with the current one. In the given example, we can observe that only two time lags, that is, the first time lag and the second time lag, have considerably high correlation, while the others have insignificant correlation. Thus, we can model the autoregressive model as AR2 model. The equation for the same is yt is equal to c plus alpha 1 yt minus 1 plus alpha 2 yt minus 2. Now that we have a good understanding of the AR model, let us use it on a sample dataset. ICC is organizing a Cricket World Cup match in the next 2 days. Cricket is a game highly affected by precipitation. Therefore, ICC has to prepare in advance. They will have to inform the match officials about rain forecasts. They even might have to schedule a reserve day. They also have to keep the groundsmen ready for any situation. Additional equipment like ground covers and rollers would have to be procured for a rainy situation. All of this incurs an additional cost. So, the ICC hires us as analysts to accurately predict the precipitation on the match day. To achieve this, you look at historical precipitation data. In this plot, the most recent values of precipitation data are shown, along with the two values that need to be predicted. We plot the PACF plot for the precipitation data. From this plot, we can conclude that only the previous time step is significant, so we can use the AR1 model for predictions. Using linear regression, we get the coefficients of the AR1 model. The equation comes out to be yt is equal to 0.85 into yt minus 1 plus 5. Here, yt is the chance of precipitation on the tth day, while yt minus 1 is the chance of precipitation on the t minus 1th day. The prediction for precipitation on the 11th is given as y11. We calculate y11 using the AR1 model. Therefore, y11 is equal to 0.85 into y10 plus 5. y10 is the precipitation chance on the 10th. Therefore, y11 is equal to 0.85 into 25 plus 5, which gives us y11 is equal to 26.25. To predict the chance of precipitation on the 12th, that is y12, we use the AR1 model. Therefore, y12 is equal to 0.85 into y11 plus 5. Here y11 is the predicted chance of precipitation on the 11th. Therefore, y12 is equal to 0.85 into 26.25 plus 5. That is, y12 is equal to 27.31. According to our predictions, the chance of precipitation on the match day is 27.31. So there would most likely be light showers on the match day. Thus, there is no need to keep an additional reserve day. In this video, we looked at the autoregressive or AR model. In the next video, we'll be looking at the moving averages or MA model.